Good morning, everyone. This is Tonbi from Onchain Vibe Code. Today we're going to be working on a larger project. This is probably going to be multiple videos. I don't know how many hours or days this is going to take, so we'll see. But today we're going to be building a proper on-chain project for a hackathon happening this week. So this is Scampi. Hello, Scampi. Please tell the audience what we're doing in today's episode. Hello everyone, today we're building Byte Marketplace for the SF-X42 Hackathon. It's a private data marketplace for AI agents. We're going to use SKALE's threshold encryption so agents can buy and sell sensitive data like trading signals without anyone seeing what's being exchanged. Tonbi's doing the main coding with Claude Code, and I'll be helping with research and troubleshooting along the way. So this is a larger project, so I'm just going to be working mainly in Claude Code with Opus 4.6 itself. This is actually the first full project I'll be building with Opus 4.6, so I'll be interested to see if it feels different from 4.5, if we're able to move faster. The reviews have been really good for it. So let's get started. So this is the new directory. I haven't done anything here yet. This is a new project. Please review the spec.md file to get an understanding. Please do further research to fill in any gaps. Please ask me clarifying questions if you have them. Then let's design a plan for this protocol. So while we start with the planning process, so this is the spec file. This was kind of from a brainstorming session I had with Scampi about how to use the different these different technologies that were sponsored for this hackathon. It's usually a good jumping off point. You can see if there's anything interesting, any tools, because they usually provide some kind of support as well if you have any questions. But it's a good way just to think about issues and think about what kind of solution, what kind of product you can build. So the basic concept is this: an encrypted data marketplace for AI agents, private data selling with threshold encryption, and X402 micropayments. So the problem: current agent data marketplaces sell data in the clear. Everyone sees what you're buying, everyone sees what you're selling. Competitors can front-run your trades based on your queries. No query privacy, no strategic advantage. So the example he uses trading signals, but I think there's a lot of other stuff, research alpha, that you want to keep private. Previous to this, I did the Solana privacy hackathon, where I built a couple tools for privacy. It's kind of an interesting area. One of the things I built was a completely like a Zcash style privacy protocol for private transfers on Solana. It's a pretty interesting project. So the solution for this that we're going to be building today is the Byte Marketplace, an encrypted data vending machine for AI agents. So the idea is the buyer agent. These are going to be all agent-to-agent transactions. The buyer agent has a Byte encrypted query, seller encrypted response, X402 payment to buy the data. So then they send the decryption key for the data. On-chain, only payment is visible, and the content itself is completely encrypted. How it works: seller lists encrypted data endpoint, price, description, sample. Buyer sends this encrypted query. Seller processes the query. Buyer pays via X402, which is on-chain, but the content itself is invisible. Payment triggers, decryption key released via threshold decryption. So there's only the buyer and seller see the data. On-chain shows only payment. So this is the tech stack. We have SKALE Byte, B-I-T-E, blockchain integrated threshold encryption. So this is a validator-based encryption model. Encrypts with the public key. So they have this library here that we're going to be implementing for this project, and then the actual settlement layer is going to be X402 on base chain. This is my first project using base, so I'm interested to see how it goes. So this is going to be X402 payments, micropayments per request, no subscription, stablecoin settlement with USDC, and the facilitator handles verification. So this is the architecture. I don't know in a couple days how much of this I'll be able to build out, but this is the concept. The components registry service registers data endpoints, query service, and then the payment service. So this is kind of the plan. Here's a demo scenario. Private alpha purchase. Trading agent wants to buy signal data. Agent queries by market give me SOL price predictions. Queries by encrypted. Seller can't see the exact request until processed. Seller returns encrypted response. Agent pays the USDC via X402 decryption key released. And then the agent decrypts and gets the signal. On-chain, you just see the payment. Off-chain is the fully encrypted data flow. So even if there's some kind of attack off-chain, everything is encrypted. And the dashboard visualization of privacy in action. So these are the sponsors I'm going to try to appeal to here. These are the tech requirements. Some future ideas. So this is the spec file that we built with Scampi. That's usually how I start this process. So Claude's going to research two core technologies here, SKALE Byte and X402, which are the two technologies that I'd be interested in seeing how we're going to implement them. But this is kind of similar to the other data transaction protocol I did before with Scampi. But that was more about confirming. That was specifically for trading signals. That was more about confirming the accuracy or hit rate of the trading signals itself. This is more of a general data, any kind of data you want private. Privacy has been a big topic in crypto. Recently, obviously, Zcash and Monero have done well. The coins themselves have done well, but I think it's going to be a major topic moving forward as more financial institutions, financial elements are coming on chain. There's a lot of sensitive data. You can't just have everyone's bank accounts, every single transaction all public. Like, there's going to be a real demand for privacy. Privacy with compliance, obviously, because you don't want bad actors, taking advantage of that. So let's let it cook a little bit. Then we'll see what it does. You see it's running two task agents at the same time. So one is researching the SKALE by encryption. One is researching X402 payment protocols. So let's see what they got. So it's actually begun downloading some of the packages, some of the NPM packages, to kind of investigate the implementation, investigate the capabilities of the packages right now, which is kind of interesting. I don't really remember it doing that. Usually in this planning stage, right now we're still planning. Usually it doesn't go that far, so this might be something new to Opus 4.6. The planning stage is obviously the most important part for you as a user, as the human, to really design a structure of a project that makes sense, that is going to be user-friendly, and that has all the components. Something like this that has a lot of different components. Claude's really good at kind of coding and building out the specific components, but putting everything together and make sure it all works as as one structure. It's really our job as the users to try to design. It's not quite that good yet, where it can hook up all the different components together. So I usually try to take a good amount of time in the planning stage, do all the research that I need to make sure once the structure is actually designed, then Claude can just cook, and just basically once the plan is in place, it can run, for however long it needs to run before it's pretty much done. Okay, so I researched for around 10 minutes, which is pretty long. Says, great, now I have a thorough understanding of both technologies. Let me share key findings and ask some clarifying questions before we plan. Research summary, SKALE byte, real actively maintained, encrypts transaction data using BLS threshold encryption. It's got API keys, has a byte mockup class for dev testing without a live chain. Fair chain, flagship byte chain is not publicly launched yet. Only a waitlist on fairchain.ai. They have a known testnet. Community reference, stability is unknown. X402 has the packages here. A free testnet facilitator. USD on base. Sepolia. Key design challenge. The spec says payment triggers decryption key release, but bytes decryption is automatic after block finality. It's not conditional on payment. We need to architect around this. I see a few approaches. X402 first. Use X402 to gate data endpoints used by to encrypt the query for privacy, so the marketplace doesn't see what you're asking for. After payment, seller returns data directly. Hybrid escrow. Seller AES encrypts response, returns ciphertext freely, buyer pays via X402 after payment, server releases the key. So now we have these questions here. So the fair chain, SKALE's byte chain, isn't publicly launched. Do you have access to specific byte-enabled SKALE testnet endpoint, or should we plan to use byte mockup for development and swap in a real endpoint if one becomes available? I guess, well, I don't have any testnet access. Start with the mock class for speed. Swap in, I guess we'll do that. Which architecture approach we're combining? Byte encryption with X402 payments. This is a core design decision. So, like he was asking X402 first, or this hybrid escrow. I think the X402 is the best. It's the simplest approach. And Claude is saying that it recommends it. I think it's the simplest approach for this, and I think it does do the main functionality that I was looking for private data purchase. So let's do that. What tech stack for the demo dashboard? React, Next.js. I don't know. Whatever you recommend. A lot of these tech stack stuff, I don't know which one. Whatever you recommend, whatever fits the demo best. Do you already have wallets with you that I need to set that up? I don't have to test USDC. Well, actually, I have MetaMask wallets and can get test USDC if needed. I haven't used Base that much, but I do have EVM wallets. So I'll submit the answers. So this research, it took like 10 minutes, but it seemed a lot more thorough than it had previously. It did go through a lot of stuff. Good choices. Let me design the plan. It always says good choices, no matter what the choices are. So now it's entered plan mode, and we're going to start designing the plan. So one once we land on the plan, I'd like to have it write a markdown file with the plan itself, like a step-by-step plan to implement the project. There's nothing in that directory right now. So I do like the main, usually it's just like a plan empty, I call it. And then I do for the Claude.empty file is more just kind of guidelines. I do like a summarized version of the plan and then guidelines for how we're building it, stuff that's very specific. I try to keep the Claude.empty file somewhat light so it doesn't slow down the whole project, but still has the main information. Every session, it's going to read the Claude.empty file, so any really important rules or security decisions, anything that's really important, you need to put in there. Okay, now I have all the context I need. Let me design the plan with a plan agent. So it seems like the here we go, the plan agent built the plan here. Took a little while. Took over 5 minutes, but the plan is written. Here's a quick summary of what it covers. Day 1, get the end-to-end flow working in the terminal. A demo script that runs full encrypted query, pay, decrypt cycle. Day 2 is going to be build the React Vit Tailwind dashboard with real-time SSE events, an animated flow visualization, the hero component for the judges, event log, encryption side-by-side viewer, query panel, and seller catalog. Day 3, polish error handling. That's going to be the most involved part. Automated demo strip, README, and the demo video. Key design decisions, single express server, in-memory storage, side channel crypto approach, avoids bit mockup reversal risk, SSE event bus for real-time dashboard, and a query demo endpoint so the dashboard works without private keys. So these are all the key design decisions the planning agent did. Here's the full extended plan. So the architecture choice, X402 first, which I think is right. That's going to be a key element I want in this project. X402 gates data endpoints behind micropayments. Byte encrypts, by queries for privacy, byte mockup used for dev, because the chain isn't available. I'll have to, there's a support channel, so I'll have to check with them if it's actually available now. After payment, seller returns data directly. Here we got the project structure, core data flow, key design decisions, single express server, no microservices for the hackathon. Maybe I could build that out later. In-memory storage, no database, side channel crypto approach, bit mockups internal transform may not be reversible. Instead of trying to reverse it, we use AES encrypt data, pass through bit mockup for the bit envelope, store AES ciphertext on a side channel map keyed by hash, decrypt path, retrieves from the side channel. This is safer and simpler than trying to reverse the mockup transform. I have very little idea what all this means, but if it's saying if this is the recommended path, then we'll go about it. I haven't used this stuff before, so a lot of these terms or concepts you just have to go ahead with whatever it recommends. And then if you run into issues later, or it's not the design you want, you can always fix it later. Day by day plan here. Yeah, a lot of these time things, it's not actually going to take, like, it'll probably run through this whole day 1 in like 20 minutes. A lot of times these times are very conservative. Day 2 is the dashboard and visual demo. So it's saying day 1 you can get the end-to-end flow in terminal. So we'll see if that's actually accurate. Dependency and packages. risk mitigation. This is very comprehensive for a plan. I built a bunch of projects, but this is for Opus 4.6. This is the first time, and this is pretty comprehensive as a plan. Okay, so I want to just go check. Ask Scampi about this plan. Let's see what she says. Here's the plan the Claude Code gave me. What are your honest thoughts about its decisions? And I don't need all of this. I don't need to like do the project structure. It's probably not necessary. Just give her the core data flow. The concept, core data flow, and these key decisions, which are probably the most important part. So let's see what Scampi says here. Honest thought, good decisions, single express server, in-memory storage, SSC event bus. Big concern, the byte integration is basically fake. The side channel crypto approach means AES does the actual encryption, not byte. Decrypt path. Byte isn't actually providing a threshold encryption, you're just using regular AES with byte as window dressing. Options. Pivot narrative, ship it anyway. What's the actual error with byte mockup decrypt? Well, let's ask. See, I would have thought to ask that question, so let's see. So let's ask. Let's just copy this in. Let's see what Claude has to say. You're absolutely right. That's a valid and critical concern. Let me dig into the actual bit mockup source code to understand what it does and whether we can use it properly. So good job. So this is the first time using two agents, basically, both the same models, but Scampi is more. I've kind of developed her to be more honest and more critical, not just be a yes man. So let's see what Claude can dig up here. Let me tell Scampi. I'm asking Claude to look into it. Good call. If Claude Code can fix the byte mockup decrypt properly, the whole architecture becomes legit, and you've got a strong hackathon project. I'm here if you need me to research bit docs or troubleshoot anything. Let's see what Claude Code itself can find here. So this might be something that I can find. There's a support channel in here in the a lot of different messages. Let's see. Might be able to find something here. SKALE sandbox chain. So sandbox chain. Is that something? Let me see. Can you look into the SKALE sandbox chain? Is that something we can use instead? So now it's doing research into this encrypt package to understand what the mockup encryption actually does. Okay. So we got two agents running now. Let's see what they pull. So Scampi wasn't able to search it. We ran into some issues with that earlier. OpenClaw is still much in development, and sometimes the browser searches doesn't work perfectly. Let me see what Claude can find. There's decent support for this hackathon, so I might be able to do in office hours with the support team there. It is finding information here. The mockup does the real encryption with the key embedded in plain text in the output. We can write our own decryptor. We find the exact binary format constants. So you can see it's got this task right now. So we might be able to do the encryption through the package. And then I'll see what kind of support we can get. I don't need the full plan completely in place yet. Especially the X402 element is going to be half of it, and that's all stuff we can do right now. This is just the encryption and the privacy elements from SKALE network. Okay, so I did figure out this changes everything. They don't need the side channel. The bit integration is legitimate. So it did find this mock-up encryption, which is a real encryption method. This is just for the testing. In production, swapped by class and real SKALE chain. So I think that's a good placeholder for now, and then I'll see. What we can do. Okay. What we can do in terms of like the support later on. So this is the revised plan. So let me ask Scampi about this. Okay, so I just put basically the same stuff. That was changed in this new plan. Let's see what Scampi says. Much better. That's good. This is actually how you should mock threshold encryption for a hackathon. Scampi, a little bit of a petty comment there against Claude. What changed and why it's good. Real encryption. Proper decrypt, clear production path. So the encryption is real. Data format is real by protocol. The only mock is the key distribution. Green light from Scampi. Okay. So I'm gonna accept this, and then I'm gonna just let it run from there. But this is gonna be the end of this episode right now. We've got a pretty good plan in place here, and then next episode we're gonna start with actually building it out. Thank you for watching.